Hi, I'm Serena from HAPS Period 1 Calculus class, and today I want to talk to you about an intro to vectors. So often we're more familiar with scalars, which are quantities with only a magnitude, such as speed, mass, or length. Vectors, however, have both magnitude and direction. Velocity, acceleration, and force are all vectors. Vectors are common in studies of physics, as many real-life forces and movements are accurately described by magnitude and direction. So to express a vector, we can use the form x, y, z with these sharp brackets. The sharp brackets indicate that this is a vector and not a point. Or xi plus yj plus zk, in which I indicates movement in the horizontal direction, J indicates movement in the vertical direction, and K indicates movement in or out of the page. Now, we can also talk about a vector in just two dimensions, x and y, like we see here. So let's try expressing this mapped vector in its component form. So let's look at the movement in the horizontal direction. From 1 to 6, which is 5. And in the vertical direction, the component is from -2 to 2, 4. So we can write this as 5, 4. Or 5i plus 4j. So the only problem with this is that it doesn't tell us where our vector starts. But this isn't really a problem because if we graph this, 2, 3, 4, if we graph this vector is the same as this one, only moved. All that matters is that it has the same slope and the same length, or the same direction and magnitude. We can also have a vector as a function of t. Let's try graphing this vector function, t squared, t. Now, each component can be viewed as a separate function. This is very similar to a parametric function. This can actually be written as x of t equals t squared and y of t equals t. Let's make a little table. T, x, and y. Let's start at -4, then -3, -2, -1, 0, 1, 2, 3, 4. So at -4, x will equal 16, y will equal -4. At -3, x will equal 9, y will equal -3. At -2, x is 4, y is -2. -1, x is 1, y is -1. At 0, both equal 0. At 1, both are 1. At 2, x equals 4, y equals 2. At 3, x equals 9, y equals 3. And at 4, x equals 16, and y equals 4. Alright, so let's graph this. So we have 16, -4, 9, -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. This function. Now, we have to add arrows to indicate the direction of the vector. So we started graphing 16, -4 and moved along in this direction. So we can add arrows that look like this. The vector moves in this direction. So, this, don't get confused with this, because as a function of t, this becomes a position vector valued function. So if you move this around, the vector will change. This would have to change if you wanted to move this function around. However, if we move this function around, it did not change the component form. So this is a little different as it is a position vector valued function. So the domain of this vector function is all real numbers because each component's domain is all real t. Just remember that we can look at these as separate functions. This can also work for finding the limit, as the limit of this vector would be infinity as t goes to infinity, because as t goes into infinity, x of t goes to infinity, and as t goes to infinity, y goes to infinity. Okay, let's try to find the domain and limit of this vector function. So remember that we can look at each of these components separately. So to find the domain of this function, let's find the domain of each one of these. So for the first part, let's find the domain of this. So t, the denominator cannot equal 0, so t does not equal 0. And we can't take the square root of a negative number, so 1 plus t has to be greater than 0. Greater than or equal to 0. We can have a 0. So subtract 1 from both sides, t is greater than or equal to negative 1. That's the domain for this part. Let's move on to the next one. ln of t over t squared. So again, t cannot equal 0. And we can't take a natural log of a negative number or 0. So t has to be greater than 0. Now in the last part, arctan of t, this is defined for all real t. So this is all real t. Now to find the domain of the entire vector, let's just look at all of these domains together. So first, we know that t cannot equal 0, that t is greater than or equal to negative 1, and that t is greater than 0. So this means that we can have from negative 1 to 0, not including 0, and then from 0 to infinity. And this is the domain of this vector. Okay, let's try to find the limit of this same vector. So again, let's just look at each of these components separately. So let's start with the first one. Limit as t goes to infinity of the square root of 1 plus t over 2t. So let's use L'Hopital's rule. This is basically 1 plus t to the 1/2. So the derivative of that, 1/2 times 1 plus t to the negative 1/2. Derivative of this over 2. So this equals the limit as t goes to infinity, 1 over 4 times 1 plus t to the 1/2. Plugging in infinity, we get 1 over infinity, which equals 0. So let's do the next part. Limit as t goes to infinity for ln of t over t squared. Again, let's try L'Hopital's rule. 1 over t over 2t, which equals limit as t goes to infinity of 1 over 2t squared. Plugging in infinity, that gives us also 0. Last one, limit as t goes to infinity for arctan of t, as we know, equals pi over 2. So to write the limit of this vector, we can just express it as the first limit, comma, second limit, comma, third limit. That's the limit of this vector. Alright, well, those are the basics of vectors without getting into calculus. I hope this was a good review for you, and thanks for watching. Bye!
Both direction and magnitude.